All right, so now we're moving on to section 17D. I'm going to try and make this video as quick as possible, but there are a few things that we need to go through. So I apologize if this video is a little bit longer than normal. But we're going to work on our axis of symmetry and our vertex. So we've already dealt with our vertex a bunch, but now we're going to start talking about what the vertex tells us about our graph. One of the things we are going to discuss is our axis of symmetry. Right, so as we have seen before, when we're dealing with quadratic functions, we know that our graph gives us a parabola, which is our U-shaped graph. Right, we know our vertex is our turning point, or the lowest or the highest point of our graph. It's where our graph starts to stop and turn back around in the opposite, or back in the same direction. Same thing, it's going up. Now it stops and turns around and comes back down. So we know that our vertex is our turning point of our graph, or it's the highest or lowest point. Well, some of the things that we're now going to discuss is what's called our axis of symmetry. We've already talked about this before briefly in a few of the other videos, but our axis of symmetry is what cuts our graph directly in half, and it makes our graph symmetrical. So our graph is symmetrical on both sides, and if we imagined that we had it on a piece of paper and we folded it on top of each other, that these two parts of our graph would fold on directly on top of each other because they are symmetrical. Right, and we can use this axis of symmetry to help us graph a little bit quicker. And also this vertex gives us our highest, so when it's facing down, it's our highest point or our lowest point. And we can use that to talk about real world applications, so our minimum and our maximum value. So today we're going to focus on our axis of symmetry. So we're going to just focus on the x value of our vertex, not so much the minimum or maximum. We'll do that a little bit, but the next section is where we will talk about that in more detail. But for now, we're going to be focusing on the axis of symmetry or vertex. And the axis of symmetry is the line that cuts our graph directly in half, so it's symmetrical on both sides. And that axis of symmetry is our x value of our vertex. So remember, our vertex we can actually write in h and k based on what we've done before. And our x value, or the h value in our vertex form, is our axis of symmetry. And it's very important when you're writing your axis of symmetry, you must write it as an equation. X is equal to, and I'm just going to put n for some number. So you don't just write the number. If our axis of symmetry is 3, you don't just write that. You say x is equal to 3. All right, so let's go ahead and go through solving this. There's an equation that we follow, and let's go ahead and solve some more problems where we're going to use this to help us to graph. All right, but before we get into anything with that, I just want to go over again. Here it would be our vertex. It's the lowest or highest point of a graph. And C, it gives us our axis of or line of symmetry. So it tells us right down our vertex that this graph is symmetrical on both sides. If I were to go ahead and fold this, if this was on a piece of paper that we can fold, these two lines that I'm highlighting now would fold directly on top of each other. And when they are symmetrical, that tells us that the distance, so here is our x-intercept B and our x-intercept A. It tells us that the distance from our line of symmetry to both of those points is exactly the same. So as we move up our graph, the distance from our line of symmetry to a horizontal line across is going to be identical. So all those green lines that I drew, these lines are going to be equal, these lines will be equal, and these lines will be equal as well. So our axis of symmetry is directly in the middle of our graph, so that all of our points, when we're the same distance away, they will be equal to each other. And as I said before, you must write it as an equation. X is equal to some number, in this case h, because we know our vertex is written as h comma k. All right, now in order to find our axis of symmetry, you could, if you want to, go ahead and rewrite this in vertex form, and we know that the x value of our vertex, the h, is our axis of symmetry. I'm sorry, I didn't mean to write x there, I meant to write h. Our h value, or the x value in our vertex form, is our axis of symmetry. So if you wanted to and you feel more comfortable with that, you can. However, sometimes when we have odd numbers, it might be a little bit more challenging for some of you guys. You seem to have trouble when we're dealing with odd numbers with completing a square. So maybe you don't want to do it that way. So what we do then is there is another formula, and it is x, our value for h, is equal to negative b over 2a. So if we want to solve for our axis of symmetry, we just need to plug it into this equation. So x is equal to negative b over 2a. So what we do is we solve for what our a is. Remember, our a is the number in front of the x squared, so it's 2. our b is the number in front of the x, 3. We don't really need c, but that's 1. And if we want to solve for our vertex, x is equal to the opposite of b, so -3, all over top of 2 times a, which is 2. And this means x is equal to -3/4. So that would be our h value. That would then be our axis of symmetry is -3/4. And this will be our line, our vertical line that goes directly down the middle of our graph, that cuts it in half. Right? So to solve for your axis of symmetry, it's actually pretty simple. -b/2a. And like I said, if you prefer to write it in vertex form, by all means you can. And remember, this is our vertex. So our vertex is -3/4k. We don't know the k value because it's not written in vertex form. But we do know that our value of x is here at -3/4. So if we know our x value and we want to solve for the y value or the k in our vertex, what do you think we need to do with this x? If we have our x value of our vertex and we're looking for the y, something we have done continuously throughout in this chapter is we can plug this back into our original equation and that will give us our y value. So once we solve for the h, we can plug in that value to then solve for the k. Or if you prefer, you can write it in vertex form and that already gives you your x and your y or your h and your k value. All right, so now remember our turning point, our vertex, tells us our minimum value or a maximum value. And a way that we know which one it is if our a is negative, so if we have y is equal to -x², if we have y is equal to -x², as we talked about before, we know that means that this graph is facing downwards. So if this graph is facing downwards, we know our vertex end has to be our highest value. Because we're going downward here and downward here, the highest we get to is this vertex and it turns back around. So when it's facing down, we will have a maximum value. And if we have y is equal to x², so our a is positive, we know that our graph is facing up, as we have talked about before, and this tells us a minimum value then. And this tells us a minimum value then, because we know that this arrow tells us our graph is continuing increasing until infinity, and this is the lowest it gets and turns back around. So when it's opening up, we have a minimum value. So when our a is negative, it tells us our graph is facing down, we have a maximum value. When our a is positive, it tells us our graph is facing up, and we have a minimum value. And as I've already talked about, if we want to find the minimum or maximum value, or that is our k value of our vertex, so the y of our vertex, we need to first solve for the x coordinate, which we already did in the last problem, -b/2a, and then we can substitute that value in for x to solve for the y. Or you could rewrite it in vertex form. It's your call, whichever one you prefer. For now, we're going to be practicing solving for our axis of symmetry and substituting it back in order to get our y value. All right, so let's go ahead and do a couple problems. All right, so we have y is equal to 2x² plus 8x plus 3, and we want to determine the coordinates of our vertex. So we need to find our h and our k value. So the first thing we're going to do is find our axis of symmetry, which we know is equal to x is equal to -b/2a, where our a is equal to 2, our b is equal to 8, and our c is equal to 3, which we don't really need in this case, but we know x is then equal to -8/2 times 2, or our x value is equal to -4. So we know our h, or our axis of symmetry, is -4. Well, if we have our axis of symmetry, or our x value, and we want to solve for the y, we need to substitute that in. So y is equal to 2 times -4² plus 8 times -4 plus 3. And now we just go ahead and work through this. -4² is 16. 16 times 2 is 32, so y is equal to 32. 8 times -4 is -32, so minus 32, plus 3. Well, these positive -2 and -32 cancel out, so that just means y is equal to 3. So when x is -4, y is 3. So that means our value for our vertex is -4, 3. And since this is a positive, our a is positive, that means our graph is opening up, which then means this will give us our minimum value. Right? This would be our axis of symmetry. X is equal to -4, and this 3 would then be a minimum value. All right, now this is why the video is going to be a little bit longer, because there are now 3 questions that we're going to do through graphing. So we're going to try and get through these quickly so that we can, but the first one, A, says find the intercepts. So when we're finding the x-intercept, we know that we need to go ahead and set y equal to 0. So this will then give me 0 is equal to negative x squared plus 2x plus 3. All right, we've already done one of these in the last section, so I'm going to go through it kind of quickly. We know that first we want this x squared to be positive, so I'm just going to multiply everything by negative 1. So that will then give me a positive x squared minus 2x minus 3 is equal to 0. This is going to factor out to x minus 3 times x plus 1 is equal to 0 because it's already a problem that we did. So x is equal to 3 and x is equal to negative 1. So it gives me the points of 3, 0 and negative 1, 0. So if you have any questions on this, please just send me a message. I know I went through it really fast, but here are our points then. Our x-intercepts are 3, 0, 1, 2, 3, and negative 1, 0. All right, to find the equation of axis of symmetry, then now after we found our x-intercept, we need to find our y-intercept. So that means that we need to set x equal to 0. So for here, we know this one's nice and easy. It's just going to be our constant, but y is equal to negative 0 squared plus 2 times 0 plus 3. So y is then just equal to 3, or the ordered pair 0, 3. So we're at 0, 1, 2, 3. So there's our y-intercept. All right, so now for b, to find an axis of symmetry, it is negative b over 2a. So we know x is equal to negative b over 2a. Well, our a is equal to negative 1, and our b is equal to 2. So I'm just going to go ahead and substitute that in. So we have x is equal to negative 2 over 2 times negative 1. So x is then equal to 1. So I know at this point here is where I have my axis of symmetry. I know my graph is going to be equal on both sides. So what I need to find now is the coordinates of my vertex. I need to know where the maximum or the minimum value is. Since this is negative, I know it's facing downward, so I know it's going to be the maximum. And I just plug that in. So for C, I just need to go ahead and plug this in. So for C, I have y is equal to negative 1 squared plus 2 times 1 plus 3. Well, this is going to give me negative 1, because 1 squared is 1, times negative 1 is negative 1, plus 2 plus 3. So y is then equal to 4. So my vertex is at the point of 1, 4. Well, here's 1, 1, 2, 3, 4. So there is my vertex. So I know that my other point has to be equal because it's symmetrical. And then how I can draw my graph. Right, my graph's a little funky. Sorry, that pad just kind of messed up a little bit. Yours should be a little, make sure that yours is smoother and not facing in like mine is there. Let me just fix that. But there is our graph. And now sketch the function showing all important features. So here we have our x-intercepts. Let me just highlight them in black. Here we have our x-intercepts. And here we have our vertex. And here we have our y-intercept. Those are important features of this graph. All right, there's still 2 more questions we need to go through. All right, so for this one, it gives us our equation already factored out for us. Y is equal to 2 times x minus 2 times x plus 4. You could multiply this in right away and then just do everything we just did in the last problem. But I'm going to show you a little shortcut here. So when we're solving for our x-intercept, that is when our y is equal to 0. So that means 0 is equal to 2 times x minus 2 times x plus 4. So right away, it's already giving us our answer because once we have it set equal to 0 and it's factored, we can set our factors equal to 0. So it's already allowing for us to solve for our x-intercepts very quickly. So it's 2 and negative 4. So we have the points of 2, 0 and negative 4, 0. So I can go ahead and plug these in already. So 2, 0, 1, 2, 1, 2, 3, 4, 0. All right, and then if we want to solve our y-intercept, it's when x is equal to 0. So y is then equal to 2 times 0 minus 2 times 0 plus 4. So this is nice and easy. We get y is equal to 2 times negative 2 times 4. So y is then equal to negative 16. All right, now I don't have room on here if I count by ones. So although I'm counting by ones on my x values, I'm going to count by twos on my y. So this would be negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, and negative 16. So I know there's my y-intercept. So just to go over something, we know that our axis of symmetry cuts our graph directly in half. So once we solve for our x-intercepts, we can solve for the x value of our axis of symmetry really quickly. And that's just finding the midpoint of these 2 numbers. So we have negative 4 and we have 2. To find the midpoint, I know this is something new, maybe you've done this before, but to find the midpoint it's you add your two x's together and you divide by 2. So it would be -4 plus 2 divided by 2. So this is -1. So we know that our axis of symmetry has to be directly in the middle of it. So it must be at -1. And once we solve for the axis of symmetry, to find our y value, we just need to plug it in. So now we don't need to multiply this through it. I know it says find the equation, so we're going to do that at the end. But we're just graphing this first. As it asks us to sketch the graph for A. So now we just need to plug in -1. So y is equal to 2 times -1 minus 2 times -1 plus 4. So now once we get our x value of our axis of symmetry of our vertex, we can just plug it in and solve for a y. So y is then equal to 2 times -3 times +3. Well, -3 times +3 is -9 times 2 is -18. So we know our vertex is the point of -1, -18. So now we can go ahead and plot that. So we knew this was -16, so this would be -18, and there's our graph. All right, so there's our graph. Now, if we want to find the equation, we just need to go ahead and multiply these. So I'm going to do this on the bottom. So it'll be y is equal to 2 times x minus 2 times x plus 4. So to solve for b, we just need to go ahead and multiply. So we'll FOIL this in. So this will give me 2 times x squared plus 4x. Whoops. And then we'll multiply into -2. So it'll be minus 2x minus 8. So y is then equal to 2 times x squared plus 2x minus 8. And now we can distribute the 2 in and get y is equal to 2x squared plus 4x minus 16. Right? So you didn't need to find the equation b in order to graph it. We could do that last. To be honest, if this was a question on a test, it probably wouldn't ask you to find the equation. It would just say graph. Right? I know I went through this one quickly. If you have any questions, please just make sure you reach out. I'm trying to make this video as short as possible. Right? There's one more question. That's it. Actually, because of the interest of time, and it's already 17 minutes, I'm going to stop this video here, and we will go over the next question in class, because I think the next one's a little bit tricky as well. So at least this way, I'm there in person when you have questions. But we'll do the next one in class. So that's it for this video.